We're looking for the solution to this system of equations that has 3 variables in it. And what we're going to do is we're going to eliminate one variable at a time until we are just left with an equation that has just one of the variables in it. The goal is to find the values for x, y, and z that will make all 3 systems, or all 3 equations in the system true. First thing I'm going to do, I'm going to label my equations 1, 2, and 3. Then I'm going to take a look at my 3 equations and decide which variable would be the easiest to eliminate in the equations. And as I'm looking at all of the coefficients, it seems like x would be the easiest one to deal with. So I'm going to focus on equations number 1 and 2 first. I'm going to multiply equation number 2 by -2. When I multiply the whole equation by -2, I have to remember to multiply every single term by -2. The reason why I chose -2 is because the x coefficient in equation number 1 is a +2. So then when I combine my 2 equations, the x's cancel out. I'm left with 7y minus 13z equals 19. Now I'm going to focus my attention on eliminating x from equations 1 and 3. So for equation 1, we start off with 2x minus 3y plus z equals -3. And in equation number 3, we have -10x plus 4y minus 6z equals 28. I'm going to multiply question number 2, or equation number 2, by 5. So then I will have 10x as my coefficient in the first equation, and a -10x for my coefficient in the other equation. My x's cancel out. I'm left with -11y minus z equals 13. And I'm going to refer to these 2 equations as equation number 4 and equation number 5. So now I get to choose which variable I want to eliminate from equation number 4 and equation number 5. And I think that z would probably be the least amount of work, so I'd only have to multiply the bottom equation by -13. When I multiply the bottom equation by -13, I'm left with 143y plus 13z equals -169. And the top equation I just get to leave by itself, because the 13z's will cancel each other out. Those are gone. I'm left with 150y equals -150. Now that I have y all by itself, I can solve for it. Y equals -1. And what I'm going to do with this -1, I'm going to plug it into equation number 5. And when I do that, I end up with negative 11 times negative 1 minus z equals 13. 11 minus z equals 13. Z is going to equal negative 2. So now I have y equals negative 1 and z equals negative 2. I'm going to plug my two answers into my equation number 1. Because I'm still looking for x, but I know that y is negative 1 and z is negative 2. 2x plus 3 minus 2 equals negative 3. Two x equals, subtract 1 from both sides. Here's our negative 4. X equals negative 2. So the answer I have right now is negative 2, negative 1, and negative 2. And that's the coordinate point that's going to work in all three systems, but I still have to check in number 2 and in number 3. So this part is where I just plug in my three values, negative 2, negative 1, and negative 2. And it works in equation number 2, and hopefully it works in equation number 3 as well. Negative 10 times negative 2 plus 4 times negative 1 minus 6 times negative 2. That should be a z, not a y. We get 20 minus 4 plus 12 equals 28. Sorry, that should be 20 minus 4 plus 12. So 16 plus 12 is 28. So here is our solution to the system, negative 2, negative 1, negative 2. And we plugged it into all three equations, so we know it works.